Hello, everyone. Welcome back. I'm Michelle Sanner, and today we're going to be talking about a couple of tips and tricks and techniques that you can use for doing scientific research, or really any research. So first, a little joke for you. Always when you start a research project, you should start with all the questions that you need to know or solve or research. So generate a list about the topic so that you can use them to guide your research. For example, if you're researching the pros and cons of nuclear power, you may ask yourself, how long has California's nuclear power plant been operating? Why has it been decommissioned? Is nuclear power safe? And by looking these questions up, researching these questions, you can kind of shape and guide the research. Okay, I always say start with Wikipedia. It's not something that you're going to cite, it's not a source, but it is a really good place to get a broad overview of a topic and kind of wrap your head around what it is you're studying. I think of it as like a jumping off point, but remember, never ever cite an article from Wikipedia. It is not considered a credible source because it's crowdsourced. So once you find good sources, great articles, things that you think you can use for your presentation, start by noting any unfamiliar vocabulary from it. You may generate further questions that you can use to then continue on and research and find new sources. Make lots of markings, mark up the texts, mark up with lots of notes, with Post-its, and I'll show you how to do this in PDF and Word as well. Here's a article I had to read when I was in undergrad in chemistry. So much of these terms were unfamiliar to me, or I wanted to make sure that I really understood. So I used the free resource, Adobe Reader, to look at articles in PDF, and you can just highlight text and add a little Post-it note for each section as you try to kind of understand and wrap your head around a text. Like I said, start with Wikipedia and take a look at good sources in Wikipedia's bibliography. This is called bibliography mining, and it's bibliography mining, and it's a very great way to find related articles that can lead you to better sources. So start with Wikipedia sources, but always be careful to double check. Sometimes what someone has said in the Wikipedia article isn't really what that source is saying. So just take the time to click through to actually read that source and take some notes off of that source. Then another really helpful tool is an annotated bibliography. So here's an example of one. I was reading a Wikipedia article on trinitratoluene, jotted down just a couple of notes, things that I thought were interesting from that article, and then read this book, The Chemistry of Explosives, and again was able to pull out a couple of relevant things for the research I was doing. So once I had a friend who used to use flashcards for this as well. And she used to put on the front of the flashcard a citation, the correct citation format of that source. And on the back, she would just kind of jot down bullet points that she had read in that source. And this is a great way to kind of organize your research if you're more of a pen and paper person. So when do we cite? Well, you don't need to cite if you are having an original idea or opinion. If it's a commonly known fact, like hydrogen has only one proton, you don't need to cite that. And if you're finding consistent information across multiple different sources. However, do cite if you are writing about something someone else wrote, someone else's opinion, someone else's research, someone else's statements, you do need to cite that. If you're finding inconsistencies between sources, absolutely do cite. If you have any reason to suspect that the source is questionable or less reliable, do cite. And if you're not sure. Now I put a little asterisk next to less reliable source, because why are you using a bad source? Well, perhaps this source is from your counter argument. You're trying to show that the opposing side has questionable or dubious research. Then of course you make sure you cite that so people don't, put that on you. The very best sources that you can use when researching are academic journals, which we'll just abbreviate by calling them journals. They're the best resources. They are required components of this project and many other research projects. They're from major publications within that field of study. And what makes them so good is that they're peer reviewed by the top researchers for accuracy and for quality. Oftentimes it can take years to review a quality study and allow it to be published in an academic journal. It's very difficult. You have to be a top researcher. You have to actually be have a very, very strong experiment and argument and case in order to be published in a journal. So these are the very best sources you're going to be looking for as you do some research. When you read a journal, start by reading the abstract. This is kind of the summary of the study and the results and what they found out. I find it most important to read the abstract to see if it's even going to be a source of information that's relevant to my project. Then I read the introduction and the conclusion first, because those tell me essentially everything that they were going to do and everything they were able to do in that study or piece of research. The methods section is usually very complex, and it kind of talks about how they conducted the experiment. This is really less relevant for you when you're doing research articles. So stick to the abstract, the introduction, and the conclusion. They're typically written in a little bit more plainer English and easier to understand, and they synthesize all that information in the methods section down to just the basic what you need to know. It's okay to only read the abstract of a journal. There's going to be many, many different journals that you find that cost money to download. And rather than do that, just simply you can use the abstract and cite information from that abstract. Here's an example of an abstract. Gives some great information without having to purchase this, this PDF of this file. And when you cite it in your bibliography, just make sure you put in parentheses, abstract only. So as opposed to you reading the whole article, you read only the abstract, and that is perfectly okay as long as you include it in your bibliography. In scientific writing, please avoid using in-text citations like this one. They tend to, I think, be very distracting and break up the text in a way that is unnecessary for science. These are typically reserved for the humanities fields. So we're going to use something different. We're going to use footnotes. So simply put endnotes or footnote notation, little tiny 1 or 2 or whatever number note that is, and include it in the very end in your bibliography or as a footnote at the bottom of the page. So that's how you should be doing your citations as you make claims in your papers. I'm going to have a whole nother video about how to use Google, but when you start with Google, please use the scholarly Google search field. So scholar.google.com in your search bar will allow you to access Google Scholar, which is a search feature of Google that really limits it, kind of filters out the nonsense on the internet and distills it down to the more educational related articles, relevant sources, good sources, and start your work from there. You can do various filters in Google Scholar. You can look at more recent articles. Here's one from 1977. That's great, except that it might be pretty outdated information right now around nuclear power reactor safety. So I might filter my search to something a little bit more recent within the past 10 years or so. There's also various other search fields you can use, and I'll talk about those in a different video. Here you have an example of the formats that this can come up. It's great if you can find articles that are in PDF format, because again, you can use Adobe Reader to annotate. And then this will help you filter your searches to kind of the most important scholastic articles. So what makes something a good source? You have to ask yourself, who wrote this source? Who wrote it? If you're researching nuclear energy, you're going to have very biased opinions from say, the charcoal industry, the coal industry, and the natural gas and the oil industry. It's going to have some pretty strong opinions about nuclear power, whereas proponents of nuclear power are also going to have some very strong opinions on their side. So think about what agenda the parties seem to have that are writing about this study. Who financed the study? And certainly follow the money. Make sure that they're not paying for a quality study. Does the publication have a mission statement? Is it peer reviewed? Is it published? Is it self-published? So peer reviewed would be the strongest, and self-published would probably be one of the weakest sources. And finally, are others citing the work? So as we look at more scholastic search tools like Google Scholar and EBSCO, which I'll talk about in another day, you can actually see how many people are citing the work, how many others in the field are using these sources as well. And from that, you can make a determination that more cited studies, more cited journals are higher quality journals, at least in their field. Bad sources. I can't tell you how many times I have gotten a Yahoo Answers source. It's amazing. But forum Q&As where anyone can just answer a question on the internet are absolutely terrible sources. Don't ever use them. Personal websites, same thing. Anyone can write anything on a personal website. Anyone can claim to be an expert. Don't include them as sources. Blogs, that's supposed to be blogs, not blogs. Blogs are terrible sources, as are unprofessional YouTube videos. The exception would be if it's from a noted publication, like if NASA had a video on YouTube, or the Institute of Air and Space, or some other professional documentary or professional publishing house. Works of fiction are also obviously bad sources. So be very, very careful when you're doing pro-con research not to allow yourself to draw a conclusion until you have completed your research. In other words, do not pick a side before you start researching. Just simply start with nuclear safety and see where it takes you and see what you learn. There may not be one single answer, and know that in science, gray area is absolutely okay. Please try to avoid language like "I've proved that nuclear power is safe" or "I've disproved nuclear power is safe." Those are absolute terms that we don't tend to use in science. Instead, use terms like "I can support a claim that nuclear power is safe," or "I am not able to support a claim that nuclear power is safe." That's a little bit better language that you can expect to use as you conduct research on this topic. All right, so hopefully this helps you kind of wrap your head a little bit around how I expect you to conduct high-level academic research for this project. We'll spend a little bit more time going in depth on Google Scholar and another resource called EBSCO another day. But for now, I hope you have a great day, and I'll see you soon.